Hi everyone, thank you for attending today's webinar, Virtual Reality Technology for Smart Manufacturing. My name is Brittany and I will be your moderator for today's webinar. Just a reminder that if you experience audio difficulties, you can connect either by computer or phone. If you are interested, feel free to follow us on social media for updates and resources we are regularly sharing, as well as upcoming webinar information. Before we get started, I do have a few housekeeping items to point out. Everyone will be muted throughout the presentation. If you do have any questions, please use the chat feature to submit those, and we will answer them during the live Q&A at the end. Today's webinar is being recorded, so you will have access to view this recording anytime you'd like at the conclusion of this presentation. Locate the settings gear in the upper left-hand corner in case you need to make any adjustments to those. With that being said, I would like to introduce today's presenter, Jeff Brum. Jeff focuses on establishing business relationships and completely understanding market and clients' interests and requirements to define unique solutions. Jeff's 10-year history with Mechdyne began as a senior marketing and global business development manager. Today, Jeff brings knowledge and technical resources to enable clients' business needs. Prior to Mechdyne, his work at virtual reality company Fake Space Systems ranged from product management and marketing to technical sales and sales support. Currently, Jeff develops and supports clients from Kitchener, Ontario, Canada, the head of Mechdyne's Global Technical Services Division. Now, without further ado, I will turn this over to Jeff to get things started.
Thank you, Brittany, and good morning, good afternoon, and good evening to everyone, depending upon where you're located. I know we have people registered from different parts of the globe, and that's fantastic. And look forward to delivering the webinar today. And while the agenda is up here and some of these things were listed in the original invitation, I want to give you some background as to how the webinar really got started, what the impetus was for it, and why we're offering it today, and especially recording it for more people to use. We had the good fortune of participating in some special events put on by the Society of Manufacturing Engineering over the past few months. We were part of the AeroDef show, Aerospace Defense Engineering event, the Rapid and 3D Manufacturing event, and very recently the Smart Manufacturing event that were put on by SME. And we participated with a large screen virtual reality display, an interactive system that was part of a larger booth that was called a virtual and augmented reality and experience. And it was really designed so that attendees at the show could come and see VR technology, AR technology in different forms, and get a sense for the technology that they might not have seen before, or talk to the technology experts to start to get an understanding of how that technology might apply in their business, and really just ask any questions in general. So the agenda is really built on the conversations that we had at all three events. There were tremendous similarities in the questions that were asked, the conversations that we had, and really regardless of the size of organization that we were talking with, people were very curious, even if they had been using in VR in one form or another, about where it could apply in different areas. So that's really where the agenda came from and what we will be covering. So the agenda allows for about 45 minutes of presentation. We'll cover everything here. We have time for Q&A, and of course, if anything is missed, there's the recording, or you can ask questions in other ways later on. So before we really get into the presentation, I would like to do this quick poll, and this is the only poll that is part of this presentation, but I just would like to get a sense of people's experience with VR. So if you would, it's a very simple click a box, and I'd just like to get an idea of how many people have the technology maybe in their businesses today, how many people have experienced their kids have it at home. I can see responses coming in, and that's great. And the reason why I wanted to put this up is just I think it will help me when I frame some of my comments later on to get an idea of people's level of experience. So I thank you. People have responded. I'm just going to skip to some of the results. And I see that actually about 50% of participants have some business experience with VR and have been familiar with it. So that's good to know. and a significant portion also have no experience with VR. So we have a bit of a range. Some have experienced it only with gaming and maybe curious about the business apps. So that's perfect. So the next slide really, again, let's set the stage a little bit with a developing kind of a shared understanding of virtual reality. There's a lot of people that maybe haven't experienced VR or have tried only the gaming part of it, or seen a stereoscopic image. But this quick slide is really about what is VR in the way that Mechdyne uses the term, or others, the way that we would like to present it in terms of this webinar. And really the ultimate goal in this is, in virtual reality, is replicating a real environment or a real model using computer-generated imagery and making it appear as if it is real to the user or users, so that they can interact with that environment or object as if they were really there. So imagine you were standing in front of your product or your factory, and how would you want to interact with that if it was a computer-generated reality? What would you need to do? You can see in the picture that the way those people are bent down, and they are obviously assessing the model, that's not something you could do at your desktop monitor. But in a truly immersive VR space, a VR experience, that is something that you can do. And really, VR's ultimate goal is to create that full sensory experience of not just sight, but being able to move and interact with that virtual object as if it was real, walking in a virtual space. The audio is a big part of that. We've even built environments with smell and special lighting and things. And the other part of VR is that, the final part I want to say is that it has been around for a number of years. People that have experience with, let's say, the consumer level head-mounted displays, or haven't heard the term, may not understand that the current HMDs are just the latest iteration of technology that's been around since the 60s. There's been many head-mounted display versions through the years. Some of them might have been the Nintendo pixelated type graphics, but depending upon the application, they were great. And then really the term VR really only got coined in 1987. So keep in mind, this is technology that's been proven. It's been proven over decades and providing value. So while we were on the booth at the show, it was also people wanted to understand the differences between virtual reality and augmented reality. And this one's slide, while I can't take credit for the two terms that are up here, works to show you how those are set apart. So virtual reality, looking at it, that the screen is your world. The computer graphics are presented to the user or users. If it's a head-mounted display, the screens are in front of their eyes, and that's the way the world is presented. If it's a walk-in virtual reality room or a VR wall, it's projected onto a screen, and that screen is the virtual space. In an augmented reality space, whether it's a head-mounted display or a tablet that you're carrying, you can still see the physical environment around you, and you are overlaying graphics on top of the real world. So the world is really your screen. You're projecting onto everyday objects, common objects, factory objects, whatever it might happen to be. And that's really a distinction that some people appreciated understanding when they were visiting the technologies at the different shows. But this, keep in mind, this presentation is really about VR, AR as a topic unto itself. So thinking about VR in particular, there were pictures before about a head-mounted display and a walk-in VR space. And whether it is a cave, that's a common terminology that some people may already know, people that are on the call, or whether it's a head-mounted display like a Vive or an Oculus Rift, the technology behind that remains very similar. Maybe different levels of complexity or different levels of power, but to create a VR experience, there needs to be some kind of interaction tool that the person has to allow them to navigate, to allow them to interact with the objects. And just the ability to interact with objects makes the difference in terms of believability that you're working with something physical. There is motion tracking. The slide that I showed at the beginning with the two people bent down and then assessing something. Their head motion is tracked, their body is tracked, their position is tracked, and that changes the image on the screens to present the data in a perspective that's correct to them. And that's important to the believability that that virtual object is real. Computing, of course, and there's different levels of computing required depending upon the graphics that you have, the level of complexity of your model, how real it is, but it's a common element. And of course, king in all of this is the software, the content that you have. What is it that you're going to display? How are you going to create it? How are you going to use it? So that's a very important part. And then there's a final little cloud over in the bottom right-hand corner that says Internet. And while that wasn't really there for those early VR experiences, or may not be necessary for a single-person experience or a particular room, it's becoming more common that whether it's the internal network or an Internet connection to a remote location, that you can share these experiences and share devices between people, whether it's in the data really, between offices, between buildings, between cities, and between countries. You can now share head mount to head mount in different locations, head mount to a cave or cave to cave. All of that is becoming possible, so that if you have distributed teams and want to get input from others on a design or on a particular approach, that is possible now, and adds a lot of potential for collaboration. So I'm going to spend a little bit of time on the technologies themselves, because a part of this is just and again, reason for the webinar, people would like to understand the differences in the tech and the considerations behind each one. So head-mounted displays, Vive and Oculus are words that people, or brands that people are maybe very familiar with. And these really came on stream in the last couple of years as they developed, particularly for gaming. And then we experienced it in particular last year, where a VP in an organization might say, my son has one of these at home, or my daughter has one of these at home, and we're using it for gaming. How could that apply to our business? And people started saying, what could I do with this, and what's the potential for it? And I think it came into the mainstream because it's now that the technology is improved over those 8-bit Nintendo versions of years ago, because the resolution has improved so much. The digital models are great representations of your data. The field of view is how much of your peripheral vision is filled, and that's very important, especially if you have a large model or a large environment, because filling peripheral vision is a very key part of feeling like you're present with a virtual object. It's now possible, I said before, to connect multiple users. Cost, of course, increases the more people you add, but if you can have people with multiple people with HMDs and they can share an environment, that adds new potential for collaboration. And really what's driving a lot of this development is that it really came out as a consumer-driven device for gaming, and then the business potential starts to arise out of that. And even the gaming companies and the software companies are recognizing that there's potential for these devices in business environments, and we'll touch on that a bit later. And then the other part of this is that wireless devices, or as these become more wireless and give you greater freedom of movement, the wires are always cumbersome, people start to adopt the technology more. So advantages of HMDs, when you think a consumer level or even a professional level HMD can be had for $1,000. You can buy it online now, not like before. And now, of course, you have to consider that there's a computer attached to that, which may even cost more to drive the level of graphics that you need and the experience that you need. But that cost level, may fit within more budgets, and it allows for some experimentation. What can we do with this technology? Let's do a trial run and see what do our models look like in stereo. What's it like to assess a model like we've never done before? And then if those companies that have experience with VR may be considering, how could we deploy this through the organization? It's a relatively low-cost tool, perhaps, and how could this be deployed to more people and make more people more effective, and that really just starts to benefit the workflow all the way through. I did mention that it's possible to connect multiple HMDs, but really as an individual device, if there was an individual task to be done, it's a great device for that. The tools that have been developed, the interaction tools are two-handed. There's a lot of potential. We'll get into that a little bit later as well. And keep in mind, and it's obvious, these take very little room. They're very portable. I'm sure you've seen them at trade shows. It's becoming a common way to demonstrate products and data. And again, as the software companies see that these technologies are becoming more pervasive and improving, they're starting to add that capability into the software. So it's, I want to display on my desktop, or I want to display in an HMD, and that is coming into more and more software packages, and just again allows that adoption through the enterprise. It's just much easier to implement. Some of the considerations. Some people find that they can't wear these devices for very long, and that's based on multiple conversations of people who use them. We even have a client who researches virtual reality or researches VR displays. They have large-scale display. They have head-mounted displays of different types, and they find that after about 15 minutes, it's just that they can't work in it effectively anymore. And whereas in a large-scale display, it can work for longer periods of time, which might be better. It all depends on what work are you trying to accomplish. How long do you need to be on the task? And discomfort may come from having worn it too long. Some people don't like putting things on their head. Some people don't like that sense of isolation and not being able to see their own hands. Not being able to see their feet and know that they're present in that space. Think again about how the device is going to be used and how you have to work with other people. If you are working with other people, how are they going to experience what you're seeing? We are seeing that, of course, if there's groups involved, one head-mounted display might be connected to a larger display so other people can see it. Is that the way it needs to be shared? Do you need to talk directly with other people at the same time? Is even facial expression important? Yes, it's possible to put avatars in these devices, in the images, so that you can see a representation of another person, but is that the most effective way to share your thoughts? And again, think about the task at hand. While you're in the VR space, do you need to take notes? How do you need to collaborate? How are you sharing? Those are all things to think about, not just in the HMDs, but also in the large-scale spaces. Final thing about HMDs, and it just plays a little more on the human factor side of it, which is, I mentioned before, is claustrophobic for some, and these parts go more toward the adoption or the people willing to use it. And maybe it's different in a business setting, but you see it particularly at trade shows or if you're doing a demonstration. Some people will not put these on. They don't react well to them. They say, I don't want to get my hair messed up, or I don't want to look silly, or I don't know what to do. And that's very commonplace. There are VPs of organizations who will not put these on because they don't want to be, they don't want their picture taken for whatever reason it is. It's the adoption of it, or the willingness to use it may be reduced in some cases. If you are in a situation or an application where you want to present to other people, think that you might need a dedicated helper who is working with people to take it on, take it off, explain how the interaction works, what they're going to experience, how they need to interact with it. And especially if you're in presenting to multiple people, that can affect your throughput. As you do one person after another, how long is that going to take? How effective is it then? How are people going to share the experience afterward? Just things to think about. In terms of large-scale VR, and again, this technology has been around for a long time, and these large-scale caves, large-scale walls came up because there are instances and applications where people wanted a one-to-one scale representation of their environment, their data, especially in automotive, where they want to feel like they're inside that vehicle. Yes, in some instances, companies are now moving some of that work to HMDs, but may still have a cave for that final decision where they want that ultimate sense of presence and can look around naturally out the windows, down at the floor, it depends on how you want to perform your work, because that sense of presence through a large-scale model is very important to some, to feel present, to have to what we call break that sense of disbelief and feel like you are present with a model. Having your own hands and feet available works for many people. A large-scale display also becomes a good team space, more people in front of it. And because you have multiple screens, or you could apply multiple projectors, if your application requires very high resolution, that can be achieved. These displays have been built up to 100 million pixels or 50 million, whatever you need. It's the level of detail you need can be accomplished with a larger scale display. There are, of course, considerations with large displays, and that ranges, the capital investment is the first thing people think about, especially when you compare directly to a head-mounted display. And yes, that's true, and it would require a business case, but there are considerations that go along with that too. The space that might be necessary. If it is a cave, which is 4 walls and a floor, or all the way up to 6 walls, that is a room unto itself and a space unto itself. And then consider that there is maintenance for any display, even a head-mounted display. There is some maintenance that's going to occur, whether it's in the software, whether it's in the display devices, and that should be allowed for. Just installing it is one thing. Keeping it going, realizing long-term lifetime value requires keeping it up to date. Consider that depending upon what you're implementing, you may want an operational resource to take responsibility for it, whether that's someone who is scheduling the system or actually operating the system while other people are concentrating on the data. Think about who's going to take responsibility for it, and make sure that it is operational when it needs to be operational, especially for vital presentations, and manage the space effectively while it's being used. And then software is a consideration for these as well. I mentioned before that some of the software companies are going direct to head-mounted displays, but they might not be going direct to these large-scale displays that could be more complex, and especially if you want the interactive capabilities associated with them. It's just one more point of investigation. So whether it is a head-mounted display or a large-scale display, I want to start touching on the opportunities in the digital workflow, because all of these display technologies can have value. And while I'm not going to read this out, and we're going to focus on some of these as we go along, suffice to say that at every stage, the technology can help. Think about your use case first, but in design, prototyping, and all the other stages of manufacturing, and even after a product's been delivered, there's opportunity to add, to improve and add value with technology. I added AR in this as well. Our focus here is VR, but I added AR just because the two, perhaps they complement, or I just wanted to show that technology does have value too. We'll talk quickly about this. This is a study that was done that really shows the opportunity to add value occurs very early in the design cycle of a product or a project, and it's in that upfront planning phase, and some would call it the design phase, where making alterations to a product to make it more serviceable, to make it easier to manufacture, can decrease the cost of manufacture, can reduce the time to decision. If those opportunities are missed up front, the cost to make changes later on really increases. If something isn't caught until it's in manufacturing stage and you have to go back to the design phase, that's lost time, that's lost money. And so the goal of this is really to say the earlier you can catch things, the greater the benefit there will be, which leads into the slide about design and prototyping, which is where a lot of VR technology started, because it was an opportunity, the VR presented the opportunity to present digital prototypes and work through those what-if scenarios. What if we made this change in the design? How does that impact the assembly process? How does that impact the manufacturing? What do we have to do? And it was an opportunity, especially with the large-scale displays, for cross-functional teams to come together, so the designer and manufacturing and engineering and the project manager can come together and understand what design impacts mean all the way through the workflow. That can have tremendous benefit, speeding time to market, the physical cost reduction of physical prototypes. And then also think that once you have that digital model of the final design or even some concepts, what can you do with those when you reach those decisions sooner, and how can you start using those designs faster? Can you start building user manuals? Can you start sharing them with sales and marketing? That digital model becomes a tremendous asset that can be used in other parts of the organization. And a big part, so you've done design, you've decided how you want to manufacture, and then the system that you have could be used for decision making. And really this is about whether you're making decisions as a team during the design process or deciding how manufacturing is going to be done, and it's collaborative, but there's also a lot of value in showing the digital model to senior management to get that final sign-off, to get approval to move to the next step, because seeing the product as it would be when it's finally manufactured, or seeing a factory before it will be designed, it's so intuitive to work through those models, to display those models, and discuss the work that went into it, that sign-off, that approvals can be done much more quickly. As I mentioned before, maybe you just have concepts or several concepts that you're deciding between. Can you show those to clients, potential clients, and get some ideas on either how to make improvements or which one is preferred? Can sales take those and start making presentations and start making advanced sales? There's opportunity, again, once you have that digital asset, to use it in different ways. From a production planning standpoint, plant design, this is something that's really come up over the past couple of years and was a topic of conversation with a lot of people at these 3 events. Was, I'm designing a new factory, or I'm going to be changing my assembly line, and I want to know that I'm doing it correctly. So whether they have a computer-generated model, or they're considering, getting a company to come in and scan the entire factory with a 3D scanner, because that's possible. And computing power is now there that you can create this giant factory model and move through it. Determine what your material flow is going to be. Comes in the raw materials come in the door, and then how is it going to work its way through the factory? What's the optimal flow? To the individual work cell design, how can you create the least number of steps for one of the workers to grab components, put them into the assembly process, or assemble them the most effective way, and have things at hand in the best order possible? Can be done different ways. There's tremendous opportunity there, and there's also the ergonomic side of it. There are things within reach. There's the safety aspect to it, of even just working in a factory or working in a hazardous setting. Those are all possible applications. Getting to the actual training side, again, especially with head-mounted displays, tremendous opportunity to do pre-assembly tasks, to do task training, to do safety training. And the rationales we hear are, well, right now I have to dedicate a supervisor or a trainer to be with that person and get them to a level of understanding on the learning curve where I can then take them into the factory and have them work on the production line. If more of that acclimation and familiarity with the environment and the tools can be done through VR, then the learning curve just increases, or the learning curve becomes much steeper, and people are acclimated before they get out on the floor. You're not impacting the actual production as much because they're already familiar with the task, or you maybe don't have to have a very expensive machine that is down or is dedicated to the training task, because you're able to familiarize the person much, much sooner. And there's opportunity with this with augmented reality as well, stepping people through assembly or stepping people through the task. Either one can apply, but it is an area of tremendous interest for many organizations. And the final slide in this area of benefits is in the service and maintenance once a product is in the field. But I'm going to go back to what I said before, that the more you can consider this up front when the design is being done, there's opportunity to avoid rework or to make it easier to service in the field. This particular image is from an organization that does take that into account. They have people in bodysuits, and they assess a design and they figure out, do I have excess? How easy is it going to be to pull out a component? How long is that going to take? And they can refine that and alter things so that they are making it easier once that product is in the field. And again, this is another opportunity for augmented reality that a person can go out to a site and they would have a step-by-step instruction overlaid onto the real world, as we showed before, or they could even call in a remote expert to give them guidance on how to do things. Forgive me, I double-clicked in when I shouldn't have. So when we've had these discussions and people are starting to understand the tech, then the question comes up, well, what software do you have on the screen here at the show? Or, here's the software that I have. Do you know if that's VR compatible? And, think about the software that you have, the CAD software or other software that you need to share with others. And there are some that do have that native capability to work with an HMD or work with a cave, as I said before. But also think that the first thing to do is to talk with your software provider. If you don't know, find out what the capabilities are or make a request, and there may be others making the same request, and see if that native capability is inherent. If it's not inherent within your software, then there are VR plugins, VR enabling plugins that are going to basically bolt onto your existing CAD software and some other applications. And then you can go direct to a head-mounted display and go direct to a cave or whatever display you might happen to have and get that immersive interactive capability. You can search those on the web. Those plugins may not give you the exact same experience and capabilities that you're going to have on your desktop, but investigate them and see what capabilities they do allow and how is that going to improve your analysis or your assessments or whatever goals you have, and they're still going to add some value. You may need to convert your data directly over into completely different software. In this instance, I'm saying a game engine. And game engine, yes, the ones that are used to design cell phone games and other games, Unity and Unreal are two packages that you might be familiar with or have heard of. And as I said earlier, those gaming companies are realizing there's tremendous opportunity in manufacturing and in other industries. So they're actually creating tools that will import CAD data very quickly, much more quickly than some other things, and convert that into the game engine software. And once you have it in a game engine, there's great opportunity to add physics if you need physics within your model, to add more realism, whether it's lighting or whatever it needs to be, to go on to these gaming packages have asset stores where you can buy, in this instance, or as the image shows, you could buy a tow motor, you could buy racking, and you could outfit an environment very quickly, very reasonably. There's just a lot of potential and flexibility with those gaming engines. You may decide that you need to create content from scratch. I mentioned before about creating a factory model, and you might have to do that with a 3D scan or build it from the ground up. But that possibility is there, and then think about how you're going to get it into VR space. Or you may want to start right from the game engine. If you're doing presenting of models and things at an event, you might just want to build from the ground up and create something that's very spectacular. But the opportunities are there, but again, this is about think about your software, think about how it's going to get into VR. There's many options. So while we have options, there's also, along with that, the considerations and implementation considerations for any of these environments and for software. And it all starts with the use cases. Think about where in the workflow could VR add the value to my organization. What is the task that needs to be performed? Who are the people that are going to do it? Who are they sharing the data with? There's a range of questions that can be asked to set out, this is what we need to accomplish. These are our goals and our objectives. And through that, think about, I mentioned range of motion before. And again, imagine if you were in front of the real model, in the real environment. How do you need to assess that? Do you need a large-scale space? Could you do it with an HMD? What kind of navigation do you need? Think about how you would work with a real object, real environment. I've mentioned this before, the level of fidelity needed. What's the level of realism to make the decisions that you need to move on to the next step? Software requirements we just covered. Bring it back to the opportunity for local and remote collaboration, especially if you have distributed teams. Will the software enable that? Will you need to, how are you going to connect it? What kind of pipe do you need? What's the network connectivity? Just things to think about. And I think I mentioned before about number of users and also your space constraints. Is this going to be at the desktop level? Are you going to need a dedicated room? If you are going to need a dedicated room, how do you justify it? How can it be used? In the early days of VR, there were many displays that were purchased, and those spaces sat idle for the good part of a week. Utilization of a device is a key thing. How much use is it going to get? How many different ways could it be used by members of your organization? And what value can that bring? So consider the utilization rate of your investment regardless of what it is. And the other elements of investment, again, there's all those things that we showed at the very beginning of the computing, the interaction, the software, the displays themselves. All of those costs are going to vary depending upon the devices that you have, the data that you have, the complexity of the models, etc., are all factors. Do you have talent in your organization that can convert models or can take the responsibility for one of these spaces? Do you need to recruit someone from a university or from wherever to have them run it? And there may be other resource considerations as well. Space we've already covered. There is a time element to this that because of the investment and depending upon the scale of the investment, you may have to create a business case. Think about budgeting cycles. If your budgeting occurs in August, when do you need to start building your business case? What kind of investigation do you need to do? How do you need to build your justification? Because in all likelihood, investment in VR may be competing against other investments in the organization. So you have to prove the value like anything else, and the investigation becomes key. And even once something is installed or even before it's installed, you have to consider the process changes. It's going to be a different method of workflow perhaps for some with it becoming digital, with VR becoming part of the regular review routine. And that may take time for people to get familiar with and things to start flowing smoothly. You will realize the value, but it may take some time to get there. And that's where that last point may come in, where considering pilot runs up front to say, let's not invest in one of these big caves like you see on the screen. Let's start with something smaller, and let's do a trial run on a particular product or in a particular area, and we're going to generate some success, and we're going to show the value, and then start to get the organization engaged that way. ROI, we talked about some of that through the other slides, and consider that there may be reduction of physical prototypes, error avoidance, rework, again, those better decisions, and it's tough to nail down the value of a decision, but perhaps it's the value of time and getting people together and how long it takes to get people together to make those decisions. Again, a little more maybe anecdotal might be what's the value of being able to enable a cross-functional team to share their models and share their data. And what's the value of getting your product to market faster? We know organizations that have calculated for every day they're late to market, they might lose X percentage of market share, they might lose X amount of revenue because they're not able to sell their product. And then mentioned before was the opportunity to perhaps pre-sell or use the VR as a sales tool, as a way that you could demonstrate to potential clients, this is how we do our development process, and what's the value of acquiring even one more client or making a large sale. I'll have an example of that later. So this is an addition to a slide that you saw before about where ROI can occur, or how ROI can occur in all those different aspects of the digital workflow. And I'm not going to read this out again. This will be available in the recording, or we can send it. But suffice to say that there are opportunities for return at every stage, and consider those as well while you're making your justifications. So in the final slides, we're going to go through some examples of organizations that have implemented VR at different scales to benefit. The first one is a defense contractor. Yes, that is a very large, involved display that is in this picture, but this organization has been using VR for many years, and they did start small. They started with smaller projects, and they started to build momentum within the organization, and they now have this type of display and larger that become collaborative workspaces. They are 2D capable, 3D capable. 3D models can be shown in context at the same time as 2D data, so they can, as a cross-functional team, work within the space, and the designers show their 3D model while the project manager looks at the timeline, while the manufacturing person considers the bill of materials, and it becomes a very productive conversation when you can display that much data and show the impact immediately and start making decisions sooner. This organization, while they were making, with each investment, really had to consider what is their return. And for some of their latest displays, they had calculated it's going to take X amount of time to deliver return on investment, but they realized the return 3 times faster than they originally thought. GE Mexico, this is a vertical wall and a floor system that was designed for their particular models, but it was used for that assembly and service planning up front during the design phase, and it was about finding those interferences early on, and it needed to be at 1-to-1 scale. And they found the value in avoiding rework, and can be significant depending upon the product and the amount of or the complexity of the service task. More on the HMD side, this was or is a government contractor, and this was a spray paint trainer. And you may think that sounds a little odd, but the particular spray paint in question was very expensive camouflage spray paint, and it became prohibitively expensive to train people using that actual paint, and it had to be the actual paint because it had very specific flow properties and was necessary. But we were able to duplicate the actual paint in VR with a real spray gun that they would use in the environment. They could press the trigger, and the flow would vary depending upon how long they pressed, and all of the spray information was captured in real time. So the trainer could actually see how much paint was the person using, how long did it take to complete the task, was there too much spray in a particular area, and all of that fed back into a report that they were able to continue to make improvements until they sent that person out to the line, and that person could begin their real work. And then it eventually got also, call it augmented reality, where the actual camouflage patterns would be overlaid onto the real vehicles, and that just made spraying easier. 2 more examples. So Genesis Systems, they are a robotic systems designer and integrator for factories. they actually had dual purpose. They wanted to be able to sell using the VR, and they wanted to be able to design using VR. So as a design tool, they could lay out a factory well in advance. Their technicians could start to run cables. Engineers could start programming based on positioning. There was a lot of benefits. And then being able to show what their design process was enabled them to go out and get new clients, and in one day realized significant sales. And as a last example, and then we'll move into conclusions, an agricultural equipment manufacturer, this was a larger scale environment, but they were developing the air handling for the inside of the cab. And by looking at the prototypes in virtual space and not building the physical prototypes, you can see the benefits in cost reductions, in reducing labor assembly time, even the design time, and that getting to market faster, just huge value. And there are other examples you can find if you search the web or if you ask for more examples, but the technology can provide value at various stages. So in conclusion to this, and then we'll move to the Q&A, really this is about the things to consider before you implement technology and implement any type of VR display. And first and foremost, consider your use cases. This is not about the technology. It's not about, oh, a cave is cool and I'm going to go buy one of those, or we need an HMD. It's really about what are you trying to accomplish. Once you know what the task is, once you know what the goals are, then start thinking about what technology is going to deliver that and deliver it in the best manner possible for the audience that you will have and the results that you expect. So, where can VR impact the digital workflow? You may be considering something just for the design phase, but again, how could it benefit the people who are planning for service and maintenance? There's a wide variety of solutions out there, and it's just about putting that all these thoughts and considerations into play early on. Consider your resources. If you have to create a justification, calculate your ROI. Think about the savings you could have from digital prototypes, even the anecdotal things about the value of bringing teams together. And then if you feel that you need to, as I said before, consider running a pilot. Start small and realize some success. Build momentum in the organization, and adoption of the technology becomes easier and easier as you go along. So with that, I'm going to conclude. We are at time for questions. Thank you very much for listening, and I look forward to any questions that you have.
Thanks, Jeff. We do have a couple questions here. The first one being, what is a good or most common VR application to start with?
Very good question. I would say it depends. It can depend on again, it goes back to where do you think you can realize value, whether it's sooner or to higher value. When VR first started out, I would say there was people looked at the design applications, and that was a great start because there was a lot of high value in design and virtual prototyping. Now, especially when recruiting might be difficult or you want to get people up to speed faster, there's a lot of interest in that training aspect, getting people acclimated to the manufacturing floor or to a particular task more quickly, and that's of high interest right now, or even the safety aspect of it. So that can be a typical starting point as well.
Great. The next question we have is, what is the cost of a large-scale display system compared to an HMD?
Cost of large-scale display, as I tried to convey during the session, can be many different configurations. Excuse me. I did say earlier that a head-mounted display you could acquire off the web for under $1,000. Then you need to compute with it, but you're still, under the $5,000 range perhaps. And I'm just choosing a figure for comparative purposes. A large-scale VR display for a single wall, into the hundreds of thousands of dollars. A cave display and larger can go into the $1 million range and larger. $500,000, $500,000 or more. It varies. I want to take it back to what data are you working with, what's the value of the potential savings, what is the right display for the task at hand. It's easy for me to say, oh, that could be $1 million, but if you can justify that, if your process improvements or your design improvements will realize that return faster or realize the return quickly, then that you can make a justification for that level of investment. But again, think about all those things about potential for ROI and compare that to the cost of the device.
Great. We do have another question here. What software for VR is mostly used, specifically to the Cave?
To the Cave, from a manufacturing standpoint, I do know that there are several CAD packages that have that native CAD or native Cave capability. The CATIA version 6, you can go direct to Cave. At these events that we were at, we were using Siemens Team Center, and that goes direct to Cave. There are some other software. VRED was one that would go to Cave, I believe, and although I think some changes have been made there. And then some of these gaming packages, while not natively capable to display in VR, there are also plugins to the gaming engines now that will make them compatible with Caves. And as I said before, the gaming engines, with their flexibility to add realism, add physics, are being looked at as a way to import all different kinds of data and make a large-scale device, even more usable.
Perfect. Next question. How hard is it to move CAD data to a game software, and what does a game engine add?
Covered a little bit of that before, but go through again to say that it's a transfer process. It's an import of the CAD data into these gaming engines. I'm going to use the example of Unreal. Unreal is one of the gaming engines that sees the potential for industrial or business applications of these devices. So they've actually created an import tool. You can find it on the web called Datasmith, and it is designed specifically to speed and smooth out the import of CAD data directly into one of these gaming engines. Say it again, it's called Datasmith, and it can reduce the conversion time from either creating a model completely or taking weeks down into potentially hours, depending upon the complexity of your data. And again, once you have it into the gaming engine, you can do the same assembly tasks, disassembly tasks, set up the physics for collision detection, and so that if you are disassembling something, you can see when it bumps or when it collides with something else. There's just and start to add some of those realistic elements that perhaps some of the CAD packages may not have. Again, it depends on how you're going to use the data.
Thank you. Where do you see VR going? Is the technology going to continue to change?
Very good question. I would say the technology will continue to evolve, and people's preferences for different applications will continue to change. I mentioned that HMDs have been around for decades. Caves have been around for decades. What's changed is I mentioned before, the resolution, the clarity of these displays, the compute power behind them to make the environments more realistic and to drive them in real time. And head-mounted displays themselves, they're not a revolution because they have been around, but they will continue to evolve. They will get higher resolution. There's been a lot of talk in the press about VR is dead and then everything's going to go to AR and augmented reality, but I would say no, VR still has its place, and now there's articles that are saying no, VR still has its place for the digital prototyping. It will be a long time before anything else can challenge the potential depending upon the application. So yes, I expect that the technologies will be around, that everything will have, any of these displays will have its best purpose or multiple purposes. Consider that as well. Again, it's if you install a display, think about different ways it could be used, but they will improve in resolution, they'll improve in the realism and abilities to interact and continue to add value.
Thank you. Just to be respectful of everyone's time, we are going to end the Q&A there. So thank you everyone for attending and submitting questions. Be on the lookout for an email with a link to the recording and a survey where we ask that you provide any feedback and submit any additional questions you may have. So with that, have a great rest of your day, and thanks for tuning in.
Thank you all.